So here's where I left off with problem 8-131. I have plotted all my points, and at the end of my video I said, well, this could probably be a rhombus or a parallelogram, but for it to be a rhombus, it has to be all equal sides, um, and it has to have those two pairs of parallel sides. For a parallelogram, it just needs to have the two pairs of parallel sides. And so let's just kind of start evaluating what this might be. Let's first look at the slopes, because slopes are going to be help me see if these are actually even parallel. The slope of this line AD, the slope of line AD, it's always rise over run. And here I have rise. I have a rise of, if I go A to D, it goes pretty much a downward rise of 1, 2, 3, 4, 5, and -5, and a run of 0. And so if you write that as rise over run, you get -5 over 0. But that doesn't work because we can never divide by 0. So the slope of AD is what I call undefined, and I'm just going to write UND, undefined. Okay? Let's look at BC because it's kind of the same thing. BC, it has a rise of, again, if I go B to C, 1, 2, 3, 4, 5 of -5 and a run of 0. That's actually the same exact slope, so I know that they're parallel. The -5 over 0, I know that they're parallel. But again, I can't divide by 0, so I want to write this that specific way to say that BC is undefined. All right, since the slope of AD is undefined and the slope of BC is undefined, those two lines are parallel to each other. Those are two vertical lines. Okay, so I know I have now one pair of parallel lines. AD is parallel to BC. Now let's talk about AB. AB, it has to go from A to B. I always like to work left to right. I have to go down 1, 2, 3. Just use my cursor. I go down 1, 2, 3, and I go over 1, 2, 3, 4. And since I went down, that's a -3. And since I went to the right, that's a +4. And so my slope for AB is a -3 over 4. All right. Now DC, again, I go down 1, 2, 3, so a -3, and then I go over 1, 2, 3, 4, and that's -3 over 4. All right, which we see right now a parallelogram. We have a pair of parallel sides AD and BC, and we have another pair of parallel sides AB and DC. Now, this is definitely a parallelogram. It is definitely, you can even look at it, say it's not a rectangle, not a square, but it could still be a rhombus. And so to figure out if it's a rhombus, it would have to have all equal sides. Well, AD and BC are nice. We can do those side lengths quickly. AD, it has this length here, 1, 2, 3, 4, 5. It has a length of 5. BC is the same. It has this length of 1, 2, 3, 4, 5. Now we just got to make sure that DC, if DC and AB have that length, then we should be good. And I am going to put it in red because I'm going to make a slope triangle here to talk about the length of DC. We said that this went down 3, so that's a -3, and it went over 4. Well, to do this, I would need to do Pythagorean theorem. I would need to do -3 squared plus 4 squared equals c squared. And I can do that, and I can say that -3 squared is 9, 4 squared is 16, equals c squared, which gives me 25 when I add them together. And that c, I'm going to run out of room a little bit here, c is really equal to 5. All right, which is actually a really interesting thing right there. Another way I could have done that instead of doing Pythagorean theorem is, I know we don't have my board in my room, but this is a Pythagorean triple. We have a short side of 3, we have another short side of 4. That means our hypotenuse has to be 5. All right. Now, if I can do this with AB and say AB is 5, we definitely have a rhombus. And so let's see what we can do here. Again, we go over, if I'm going left to right, I go over 4 and down 3. So over 4, down -3. I can already see, and I hope you can too, that this is the same triangle, -3, 4. And so that my length here has to be 5. Has to be 5 right here. And so I actually do have a rhombus here. All the side lengths are 5, and I have the 2 sets of parallel lines. And so if I answer A, if I go up and answer A, I get to say that this is a rhombus. It's the best I can do. All right. The next part is we need to find the area. We need to find the area of A, B, C, and D. And it's really not too bad. Even with the markings I have on here, they actually help me now. I have when you're finding the area of a parallelogram or a rhombus, it's just base times height, and I have this base of 5 and this height here of 4, and so really all I have to do is multiply 5 times 4, and I should get my area here. And so if I do 5 times 4, I get that is 20 units squared for my area of this rhombus here. Just doing that 5 is my base and 4 is the height. And remember, height is not this diagonal line. Height has to be a straight line that goes from, I could also translate that 4 down to here. Maybe that would help you see it. That height right there is also 4. But we just did base times height for the area of a rhombus. The next part here, part C, it says find the slope of the diagonals AC and BD. I'm going to do some erasing here. Try to clean this up just a little bit. So I got to find the slope of AC here. I'm going to put a line in. AC and BD. I'm actually just going to start with AC so we can see it a little bit better. This AC line has a slope. I always, again, like to work left to right. It has a slope of 1, 2, 3. I should make the markings. I'll put that in red. Right here. It looks like it goes down 1, 2, 3, 4, 5, 6, 7, 8. It looks like it goes down -8. And it looks like it goes over 1, 2, 3, 4. Which gives me a rise over a run. I'm going to keep it in red, of -8 over 4, which reduces down to -2. So it has a slope, AC has a slope of -2. All right, I'm going to erase that, and I'm going to do BD now. B to D here. And I'm going to work left to right. I go, it looks like I got to make sure I'm in red, over and then up. And that looks like I went up 2. And it looks like I went over 1, 2, 3, 4. And so I have a rise of 2, a run of 4. So that's 2 over 4, which reduces down to a positive 1/2. For BD. And if I look at these two slopes, these are actually, and I can put this -2 over 1, and then it maybe helps you see that these are opposite reciprocals, meaning that they have been, if you go -2 to 1, the numerator and denominator have been flipped and made positive. And so reciprocal means that that's been flipped, and opposite means that it's an opposite sign. So if that one's negative, this one is positive. And when we have opposite reciprocal slopes, that means these two lines, these two diagonals are perpendicular to one another. And so if I wanted to, I could actually put a 90-degree angle in there because I know that those two lines are perpendicular based on their opposite reciprocal slopes. All right, last part here. It wants us to find the point of intersection of these two diagonals. And then it's saying, what is the relationship between the point and the diagonal of AC? D, when we're finding this point of intersection of the diagonals, there's a long way we could do it to plug in with their equations and use like substitution or elimination to solve our two equations for x and for y. But I don't want to do it that way. I just want to look at our diagram and then evaluate what's going on here. And so if I'm looking at the diagram, these 2 points intersect, or these 2 lines, I should say, 2 diagonals, intersect right here. All right? They intersect right there. And that point that they intersect, right there is at, it doesn't go left or right, and so your x coordinate is 0, because it doesn't go left or right, and it goes up 2. And so that coordinate there, the intersection point is at 0, 2, and I'm going to put that down here now. Is at 0, 2. All right, and then the part it says, what is the relationship with AC? Well, to me, I think that point might be the midpoint of AC. So let's try to find what the midpoint of AC is to either confirm or deny that idea. We have A here and C here in midpoint. What do? You're going to add your x's together, divide them by 2. You're going to add your y's together and divide them by 2. And so let's add our x's, -2 plus +2. -2 plus a +2. Divide that by 2. That's going to give me -2 is 0 over 2, which gives me 0 for x. All right. And if I want to find my y coordinate of my midpoint, you got to add them together and divide by 2. What I get is I get 6 plus a -2. So 6 plus -2 divided by 2. 6 plus -2 divided by 2. 6 plus a -2 is 4 over 2, which gives me 2, which gives me a coordinate of 0, 2. And so my theory was right. I have this point here, that intersection point was at 0, 2, and it was also the midpoint of my line. And what that tells me, and this is really just reassuring some ideas we did before, is that those lines are bisecting one another, or that AC is getting bisected by BD. And really what we showed here was, well, we showed that a rhombus has all equal sides, and we did that. We showed that the diagonals are bisecting one another. We showed that the diagonals are perpendicular to one another. And again, we're just confirming a bunch of stuff that we learned about rhombuses in the previous chapter. All right, I'm going to probably get 132 done here, and then I'll finish 133 in a really short third video. But let's take a look at 132. So it's just saying, look at these triangles, which are not necessarily drawn to scale, and say if they're congruent, and if they're not congruent, explain why. That's pretty much all of it. And so it goes by pretty quickly. This is just bringing back stuff we've seen in chapter 7. I think chapter 7 or chapter 6 was more triangle congruence without the proofs. So let's look at A here. And as I look, I only have about a minute left, so I'll do A, and then I'll finish up the rest in the second video. It still will be short for the third video because it's really just B and C, which are not very long, and then 133 is not a super long problem either. All right. And so let's look at A. A has angles here that are congruent, a pair of sides that are congruent, and it has a shared side right here. All right, and if I look at this, it goes side, angle, side, and side, angle, side is one of our types of congruence. And so what we have here is that triangle A, B, D is congruent to triangle CBD, and they are congruent through side angle side congruence. And that's the part A.